There is a star you will never see, not because it's too dimmed, not because it's hidden behind a cloud or a mountain or the glare of a city sky, not because your telescope isn't powerful enough or your eyesight isn't sharp enough, but because tonight, right now, while you are sitting here, that star crossed the line. A line the universe drew without asking your permission, and the moment it crossed that line, its light stopped being able to reach you forever. Not for a very long time, not until we build better telescopes, not until some future civilization figures out a workaround. Forever. The light that star is firing into space right now, the light it will fire for the next billion years will never, under any circumstance, reach your eyes, or your children's eyes, or the eyes of anyone who comes after you. The universe between you and that star is expanding so fast that light, the fastest thing that exists, is losing the race. It is running toward you at 300,000 kilometers per second and falling further behind every second it travels. You didn't feel it happen. There was no sound, no signal, no warning. A star just left your universe. And here's the part nobody tells you. That isn't a rare event. That isn't a cosmic anomaly that happens once in a billion years. That is happening constantly. Right now, as you breathe, as your heart beats, thousands of galaxies are crossing that line every single second. Whole civilizations of stars, billions of suns sliding silently beyond a horizon you cannot see, cannot touch, and cannot stop. The universe isn't infinite, it's a shrinking room, and the lights are going out one by one. I'm going to show you exactly how trapped you are, and why the trap has been closing since the first second of time. Every picture of the universe you've ever seen is technically accurate and completely misleading. Let me show you the mental image you're carrying. The one that feels so natural, so obvious, so correct that you've never once stopped to question it. You picture the universe as a map, an enormous expanding map stretching in every direction, up, down, left, right, forward, backward, without limit. Galaxies scattered across it like cities on a globe. Clusters and filaments and vast empty voids between them. And the map just keeps going. Zoom out far enough and there's always more. More structure, more galaxies, more universe. You've seen the images from the Hubble Space Telescope. The deep field photographs where they pointed the telescope at a patch of sky the size of a grain of sand held at arm's length. A patch that looked completely empty to the naked eye. And in that grain of sand-sized emptiness, they found 10,000 galaxies. 10,000 entire galaxies in a speck of nothing. That image does something to your brain. It makes infinity feel real. It makes the universe feel genuinely boundless. Like no matter how far you go or how deep you look, there will always be more. Stop. That feeling is the trap. Not because the image is wrong. The Hubble deep field is real. Those 10,000 galaxies exist. But the image accidentally teaches you something false. It teaches you that more powerful observation always means more universe. That the boundary of what we can see is purely a technology problem, a telescope problem, a telescope problem, a patience problem. It isn't. Here's the first crack in the map. The universe is approximately 13.8 billion years old. Light travels at a fixed speed. So the maximum distance light could have traveled since the Big Bang is 13.8 billion light years, right? Wrong. Because while light was traveling, space was expanding. The galaxies that emitted the oldest light we can detect have been carried away from us by expansion. Today, those galaxies are not 13.8 billion light years away. They are approximately 46 billion light years away. The observable universe, the sphere of space we can theoretically detect, has a radius of 46 billion light years, not 13.8 billion. But here's what the map doesn't show you, what no pretty image ever shows you. Beyond that 46 billion light year sphere, there is a second boundary, a harder boundary, a boundary that has nothing to do with the age of the universe or the speed of light in a static space. It is the boundary where space itself is expanding faster than light can travel, and beyond that boundary, light doesn't just take a long time to reach you. It can never reach you. Not in 13.8 billion years. Not in 13.8 trillion years. Not M. The map doesn't end because we ran out of universe. The map ends because the universe ran away from us. Our horizon isn't a wall the universe built. It's a wall that expansion built. And here's what makes it terrifying. It's not in front of you. It's all around you. Before we go further, we need to rebuild from the ground up, because the word horizon is doing enormous work in this story. And if you're carrying the wrong definition, everything that follows will feel like magic instead of physics. So let's define it properly. You already know what a horizon is in everyday life. Stand on a flat beach. Look out to sea. There's a line in the distance where the ocean appears to meet the sky. Ships beyond that line are invisible to you, not because they disappeared, not because they don't exist, but because the curvature of the earth drops them below your line of sight. Walk toward that horizon and it moves away from you. Sail toward it and it recedes. The horizon is not a feature of the ocean. It is a feature of your position and your geometry. The cosmic horizon works on the same principle. But instead of the curvature of a planet limiting your view, it is the expansion rate of space, limiting what light can ever reach you. Here's the reframe. And I need you to sit with this carefully because it's the engine of everything that follows. Space is not empty. Space is a fabric, and that fabric is expanding. Every point in space moving away from every other point, like dots drawn on the surface of a balloon being inflated. The farther apart 2 points are, the faster they move apart. Not as air moving through space, but because the space between them is growing. Now, here is the crucial consequence. There is a distance at which 2 points are so far apart that the space between them is expanding faster than light can cross it. At that distance, light fired towards you is not moving in the wrong direction. It is moving towards you at 300,000 kilometers per second. But the space it has to cross is growing faster than it can cross it. It's like running up a down escalator that accelerates the higher you climb. You can run as fast as physics allows. You will never reach the top. That critical distance, the distance at which the expansion speed of space equals the speed of light, is called the Hubble radius. It currently sits at approximately 14 billion light years from Earth. Beyond the Hubble radius, space expands faster than light. And here's where it gets genuinely strange. The Hubble radius is not the same as the cosmic horizon. Stop, because here's something that sounds impossible, but is absolutely true. Light from beyond the Hubble radius can still reach us. How? Because the Hubble radius itself moves over time. As the universe expands, the Hubble radius shifts, and light that started its journey in a region where space was expanding faster than light can, over billions of years, gradually work its way into a region where space is expanding slower than light, and eventually make it to us. The true cosmic horizon, the cosmological event horizon, sits farther out than the Hubble radius. It currently sits at approximately 16 billion light years, and it marks the boundary beyond which light fired today will never reach us, not in any amount of time, not under any conditions. So we have 3 boundaries, and understanding all 3 is what separates a confused picture from a clear one. First, the observable universe, 46 billion light years. Everything whose ancient light has already reached us. Second, the Hubble radius, 14 billion light years, the distance at which space currently expands at the speed of light. Third, the cosmological event horizon, 16 billion light years, the distance beyond which light fired today will never reach us. These are 3 different walls, 3 different layers of the shrinking room, and the room is getting smaller. The lighthouse isn't going dark because it's far away. It's going dark because the universe is stealing its light before it can reach you. Now imagine this, and I want you to really build this picture. Close your eyes after I set the scene if it helps. You are floating in space. No planet beneath you, no atmosphere. Just you and an infinite dark ocean of stars in every direction. And somewhere out near the edge of what you can see, right at the boundary of your cosmic horizon, there is a lighthouse. Not a metaphorical lighthouse, a literal one. A beacon firing pulses of light towards you once per second. Flash, 1 second. Flash, 1 second. You can see it, faint, but there. Ticking reliably in the dark. Now the universe starts expanding. At first, nothing seems to change. The lighthouse is far away, but its light is still reaching you. Each flash still makes the journey, faint but arriving. But here's what's happening to those flashes as expansion accelerates. Each flash leaves the lighthouse traveling toward you at the speed of light. But the space it has to cross is growing. Every second that flash travels, more space is being created between it and you. The flash is moving at full speed. It is doing everything physics allows, but the distance it needs to cover keeps increasing. Stop. Now watch what happens to the timing. The first flash left the lighthouse when it was, say, 15 billion light years away. It arrives. You see it. The second flash left 1 second later. But in that 1 second, the lighthouse moved slightly farther away because space expanded. So this flash has a tiny bit more distance to cover. It arrives, but slightly later than you'd expect. The gap between flashes is stretching. The third flash, more distance, longer gap, the fourth, the fifth, the gaps keep stretching. From your position, the lighthouse appears to be slowing down, ticking less and less frequently. 1 flash per second becomes 1 flash per minute, then 1 per year, then 1 per century, and then, not with a bang, not with a dramatic announcement, the flashes stop arriving altogether. The lighthouse hasn't gone dark. It is still firing pulses every second. It will fire them for billions of years to come. But those pulses are being fired into a region of space that is expanding away from you faster than they can travel. They are running toward you at maximum speed and falling further behind with every passing moment. The lighthouse is still there. You just can never know that again. Now here's the part that makes this more than a thought experiment. That lighthouse is real, except instead of a lighthouse, it's a galaxy. And instead of you floating in space, it's every telescope on Earth. And instead of one lighthouse, it's every galaxy beyond our cosmological event horizon. Right now, there are galaxies that crossed our horizon in the past, whose light is still reaching us, ancient light, fired before they crossed the line, still making its way toward us across billions of light years. We can see them, we can study them, we think of them as part of our universe, but they aren't anymore. They crossed the line. The light they are firing today will never reach us. We are seeing their past, not their present. We are looking at ghost, light from objects that have already structurally, permanently left our universe. And the galaxies approaching our horizon right now, their clocks, from our perspective, appear to slow down. Their light redshifts stretches to longer and longer wavelengths as expansion carries them away. They fade from blue to yellow to red to infrared to microwave to radio. They dim, they slow, they approach but never quite reach complete invisibility, just an asymptotic fade toward nothing. The universe doesn't slam a door shut on them. It just turns down the volume until there's nothing left to hear. We didn't theorize the horizon, we photographed it. And what the photograph shows us is more claustrophobic than anyone expected. Here is where this stops being a thought experiment and becomes something you can hold in your hands. In 2013, a space telescope called the Planck satellite, operated by the European Space Agency, released the most detailed map ever made of the oldest light in the universe. It's called the Cosmic Microwave Background, the CMB, and it is, in the most literal physical sense, a photograph of the cosmic horizon. Let me explain what that means. In the first moments after the Big Bang, the universe was a plasma, a dense, hot, opaque soup of particles so energetically chaotic that light could not travel through it. It was like trying to shine a flashlight through a brick wall. Every photon fired in any direction immediately collided with a particle and got absorbed, re-emitted, absorbed again. The universe was completely opaque. This continued for approximately 380,000 years. Then, as the universe expanded and cooled, something extraordinary happened. The temperature dropped to the point where electrons could combine with protons to form neutral hydrogen atoms. And the moment that happened, the universe became transparent. Light could suddenly travel freely. The photons that had been trapped in that opaque plasma were released, all at once, in every direction, filling the universe with a flash of light. That flash is the CMB. That light has been traveling for 13.8 billion years, and here is what makes it a photograph of the horizon. That CMB light represents the maximum distance from which any light can have reached us since the universe became transparent. It is the oldest light we can ever see, not because older light doesn't exist, but because before 380,000 years after the Big Bang, the universe was opaque. There is no light from before that moment that can ever reach us. The CMB is the wall of our observable universe, the hard edge of our shrinking room. Stop. And what does the photograph show? It shows a nearly perfect sphere of microwave radiation, almost completely uniform in temperature, about 2.7 degrees above absolute zero, with tiny fluctuations of about 1 part in 100,000. Those tiny fluctuations are the seeds of everything. The slight density variations in the early universe that gravity amplified over billions of years into the galaxies, clusters, and filaments we see today. But here's the engineering fact that proves the horizon is real. Not theoretical, not philosophical, but measured. The Planck satellite's measurements of the CMB have allowed physicists to calculate the geometry of the observable universe with extraordinary precision. The size of the horizon, the rate of expansion, the density of dark energy driving that expansion, and every single measurement confirms the same conclusion. The expansion is accelerating. Dark energy, the mysterious force driving the universe apart, is not slowing down. It is speeding up. The horizon is not static. It is not stable. The cosmological event horizon is getting closer to us over cosmic time as expansion accelerates. We didn't guess that the room was shrinking. We measured it with a satellite, with precise instruments, with numbers that have been checked and cross-checked and verified by multiple independent observations. The shrinking room is not a metaphor. It is a measurement. The ant isn't moving backward. The ground beneath it is being manufactured. And no matter how fast the ant runs, the universe makes more ground faster than it can cross. Now we go deeper. Now we introduce the twin of the horizon, the other half of the story that most explanations skip entirely because it sounds too strange. Let me show you with the simplest possible picture. Imagine a rubber band stretched between two thumbtacks on a table. On one end, a tiny ant. On the other end, a sugar cube. The ant wants to reach the sugar. It starts walking. Now I start stretching the rubber band. Not fast at first, just slowly. The ant walks. The rubber band stretches. The sugar cube moves away. But the ant is making progress. Its position on the rubber band is advancing even as the total length of the band grows. Given enough time, it might still reach the sugar. Now I stretch the rubber band faster, much faster, faster than the ant can walk. Stop. Is the ant moving backward? No. The ant is still walking forward at exactly the same pace. Its feet are moving. It is covering ground. But the ground itself is being stretched beneath it faster than it can walk. New rubber band, new space is being created between the ant and the sugar faster than the ant can cross existing space. The ant is not failing to run fast enough. The ant is running into a universe that is manufacturing distance faster than any speed can overcome. This is precisely what happens to light from beyond the cosmological horizon. The photons are not slow. They are not blocked. They are moving at the maximum speed physics permits. But the space between them and us is expanding faster than they can cross it. More space is being created, genuinely created, from the quantum fabric of the universe, faster than light can traverse existing space. Now here's the evil twin of the horizon, the concept that pairs with it exactly the way time dilation pairs with length contraction. We've talked about the cosmological event horizon, the boundary beyond which light fired today can never reach us. That's our horizon looking outward, our limit on what we can receive. But there is a mirror image horizon, one that defines what we can ever affect. It's called the particle horizon, and it defines the boundary of everything we could ever send a signal to, everything we could ever influence, contact, or reach. Think about what that means. Right now, in this moment, there are regions of the universe, vast, galaxy-filled regions that we cannot receive signals from and cannot send signals to. They are beyond both horizons simultaneously. They are not just invisible to us, they are causally disconnected from us. Nothing we do can ever affect them. Nothing they do can ever affect us. They might as well be a different universe. And here is where the analogy chain deepens into something genuinely disturbing. You remember the rubber band, the ant walking, the space being manufactured faster than it can be crossed. Now imagine that the rate of stretching is accelerating. The rubber band isn't just expanding at a constant rate, it's expanding faster and faster every second. The ant isn't just struggling to keep up. The gap between the ant and the sugar is growing at an exponential rate. This is exactly what dark energy is doing to our universe. Dark energy, the mysterious energy embedded in the fabric of space itself, is not constant in its effect. As space expands, there is more space, which means more dark energy, which means faster expansion, which means even more space, which means even more dark energy. It is a self-reinforcing cycle, an accelerating expansion with no known break. And what does that accelerating expansion do to the shrinking room? It shrinks the room faster. The cosmological event horizon, due currently about 16 billion light-years away, will actually stabilize at a finite size as the expansion reaches a steady exponential rate. But that stabilization means something devastating. It means every galaxy currently beyond that horizon will permanently recede. And every galaxy currently close to that horizon will eventually cross it, one by one, silently, without announcement. The room doesn't shrink to zero, but it shrinks to something finite, something bounded, something that contains a tiny fraction of the universe's total content. We are the ant. The sugar cube is infinity, and the rubber band is being stretched by a force we don't fully understand, accelerating away from us, manufacturing the very distance we are trying to overcome. In 1 trillion years, every galaxy beyond our local group will be gone. Not dead, not destroyed, just permanently, structurally invisible. The universe will look empty, and whatever intelligence exists then will have no way of knowing it wasn't always. This is where everything we built, the disappearing star, the lighthouse fading to silence, the ant on the accelerating rubber band, the photographed wall of the CMB, converges into a single consequence so vast and so final that physicists have given it a name: the Great Cosmic Forgetting. Here is what happens to the universe over time. Not in billions of years, but in trillions. Right now, our cosmic neighborhood contains the Milky Way and a collection of nearby galaxies called the Local Group, the Andromeda Galaxy, the Triangulum Galaxy, and about 50 smaller companions. The Local Group is gravitationally bound. The galaxies within it are close enough that their mutual gravity overcomes the expansion of space. They will not drift apart. They will eventually merge into a single enormous galaxy, sometimes called Nocometa, and that merged structure will persist essentially forever. Everything outside the Local Group is a different story. Every galaxy cluster beyond our gravitational neighborhood is being carried away by expansion. Right now we can see them. We can measure them. We can map their positions and study their properties and trace their histories. The Virgo cluster, the Coma cluster, the Perseus cluster. Thousands of galaxy clusters, each containing hundreds or thousands of galaxies, each galaxy containing hundreds of billions of stars. All of them are leaving. In approximately 150 billion years, about 10 times the current age of the universe, the nearest galaxy clusters will have crossed our cosmological event horizon. Their light, fired from that moment forward, will never reach us. They will be gone, stopped, not dead, not destroyed, not dented in any dramatic way, just unreachable, invisible, erased from our observable universe as completely as if they had never existed. And then the forgetting accelerates, cluster by cluster, galaxy by galaxy, star by star, not individually, but whole populations vanishing beyond the horizon as their host galaxies are carried away. The cosmic web, that beautiful, intricate structure of filaments and voids that we see in our deep field images, will dissolve from our view. The universe will begin to look empty, not because it is empty, but because its contents have been stolen by the horizon. In 1 trillion years, a number so large it barely means anything. The night sky of whatever civilization exists in the Milky galaxy will be almost perfectly dark. No visible galaxies beyond their own merged structure. No cosmic web, no deep field of 10,000 galaxies and a grain of sand, just black. And here is the part that should make you feel genuinely claustrophobic. Whatever intelligence exists in that far future will look up at their empty sky and have no way of knowing what we know right now. They will have no evidence of the cosmic web, no light from distant galaxy clusters, no CMB, because even that ancient radiation will have redshifted beyond any possible detection, stretched by billions of years of expansion into wavelengths so long they carry almost no energy. They will have no way of knowing the universe was ever full. They will look at their empty sky and their physics will tell them the universe is their galaxy and nothing else. Their cosmology will be wrong, permanently, irrecoverably wrong, not because they are less intelligent or less curious or less scientifically rigorous than us, but because the evidence will be gone. The universe will have eaten its own history. Stop. Now turn that around and face it directly. We are living in the most cosmologically rich moment that will ever exist for any observer in our region of the universe. Right now, today, we can see galaxy clusters that will be invisible in 100 billion years. We have access to evidence that will be permanently destroyed by expansion. The CMB, our photograph of the horizon, will eventually redshift into undetectability. We are looking at a universe that is in the process of erasing its own biography, and we happen to be alive at the one moment when enough pages are still legible to read the whole story. The shrinking room hasn't closed yet, and every second it gets smaller. And the most devastating truth of all, the civilizations that will exist in the far future, staring at their empty sky, will not know what they lost. They will not feel the loss. They will not mourn the galaxies that vanished. Because you can only miss what you knew existed, they will never know. Only we know, right now, in this moment, while the lights are still on. You are not trapped in a small universe. You are trapped in the universe that is erasing itself and calling it expansion. So here we are. We started with the star leaving your universe without warning. We watched a lighthouse fade to silence, not because it went dark, but because space stole its light in transit. We watched an ant walk heroically toward a sugar cube on a rubber band being stretched by a force it cannot fight. We looked at a photograph of the horizon, a real image taken by a real satellite, and saw the wall of our shrinking room printed in microwaves. And now, I want to give you something to take away. Not just the vertigo, not just the scale, something that reframes what all of this actually means. Here is the metaphor I want you to carry. You are in a room. The room is enormous, 93 billion light years across. So vast that the number is essentially meaningless to human intuition. But it is a room. It has walls, and those walls are not static. They are not moving toward you exactly, but the contents of the room are being pushed through the walls by a force embedded in the fabric of the floor and ceiling and air itself. Every second, something that was inside the room is outside the room. Every second, the room contains slightly less. The prison grows, but the prison empties. This is the strange paradoxical geometry of our situation. The universe is getting bigger. Space is expanding in every direction. The total volume of space-time increasing every second. And yet the observable universe, the only universe we can ever access or know, is shrinking, getting emptier, getting quieter, getting darker. We are in a growing prison that is losing its furniture. Stop. But here is the reframe I want to offer. Because the shrinking room is only terrifying if you think of the horizon as something being done to you. What if you thought of it differently? The horizon is not a punishment. It is not evidence of a hostile universe conspiring to limit your knowledge. It is a consequence of the same expansion that made galaxies possible in the first place. Without expansion, the universe would have collapsed back on itself in the first second. Without expansion, there would be no structure, no stars, no planets, no chemistry, no you. The very force that built the shrinking room is the force that built everything worth seeing inside it. The horizon is the price of existence, and there is something else. something quieter and more personal. Think about what it means that we can see the CMB at all, that ancient light, fired 380,000 years after the Big Bang, when the universe first became transparent, has been traveling for 13.8 billion years to reach the Planck satellite's detectors. It crossed the entire observable universe. It survived expansion, redshift, the formation of galaxies, the deaths of stars. It arrived. We caught it. We built instruments sensitive enough to detect microwave radiation carrying 1 part in 100,000 temperature variations across the sky. We decoded those variations and read in them the seeds of every structure in the observable universe. We held the universe's baby photograph in our hands. The shrinking room is real. The horizon is real. The horizon is real. The great cosmic forgetting is coming. But right now, in this moment, the room is still lit. And you, with your curious mind and your pattern-seeking brain and your ability to sit still long enough to follow an idea from a disappearing star all the way to the heat death of cosmological knowledge. You are the universe's mechanism for knowing itself before the lights go out. The horizon doesn't make the universe meaningless. It makes right now irreplaceable. Every observation made today, every photon caught, every galaxy mapped, every CMB fluctuation measured, is a piece of evidence that will eventually be destroyed by expansion. We are the only moment in the history of our region of the universe when this evidence exists and minds exist capable of reading it. We are not trapped in a shrinking room. We are the room's last librarians, and the library is the most extraordinary one ever assembled. So the next time you look up at the night sky, at the stars you can see with your naked eye, at the faint smear of the Milky Way on a dark night, you'll know something most people don't. You'll know that what you're seeing is not the universe. It is your universe. The contents of your shrinking room. The light that made it to you before the expansion could steal it. The survivors. And somewhere beyond what you can see, beyond the cosmological horizon, beyond the reach of any telescope ever built or imaginable, there are galaxies firing light in every direction right now. Light that will never reach you. Stars being born, living, dying in complete and permanent isolation from your observable universe. Events happening right now that you will never know about, that no descendant of yours will ever know about, that no intelligence in your cosmic neighborhood will ever detect. The universe is vast beyond comprehension, and you are allowed to know only a fraction of it. Stop. But here is the question this leaves open, the one that keeps cosmologists genuinely unsettled. If our observable universe is a finite room inside a larger universe, if the horizon is a local boundary, not a universal one, then what is the larger universe like? Is it infinite? Does it have structure beyond our horizon? Are there other regions where expansion happened differently, where the physics settled into different constants, different forces, different rules? Is our universe one room in a much larger building? That question has a name. It is called the multiverse. And the answer, if there is one, reaches into the deepest implications of inflation theory, quantum mechanics, and the fine-tuning of physical constants in ways that will make the cosmological horizon feel like a warm-up act. If you want to understand what exists beyond the wall, if you want to know whether the prison has neighbors, then you are going to want to be here for it. The next video is already waiting. Subscribe and we'll go there together. The lights are still on. Let's use them.